What's up guys, Rishi here. Welcome to the Tech Talk podcast. Hello.
Hi Rishi, how are you?
Hi Jami, happy to have you on the podcast. Can you
It's
quickly introduce yourself?
Sure. My name is Jamie Taylor. I sometimes have the use the online moniker Gaprogman, Gaprogman, and I'm the host and creator of the .NET Core Show. I've written about .NET Core for around 2 years now. So yeah, I'm a bit of a .NET maniac, I think.
You are specialized in .NET. Now, we were going to talk about Blazor today, but before we do that, I would like to talk a bit about WebAssembly. Browser is the biggest runtime in the world, so more people run software in the browser than anything else. At least until now, it was limited to JavaScript, but this changed now, especially because of WebAssembly. Now we are able to use all type of languages, managed languages such as Java or .NET, low-level languages such as plain machine code or C, which are closer to the hardware than high-level programming languages. It's worth mentioning that it is not regular assembly, it is not x86 machine code or any other instruction that runs directly on the CPU. Here where's Blazor come into the picture, because Blazor is supporting the WebAssembly. Can you tell me a bit what Blazor is?
Okay, so Blazor is a combination of browser and Razor. So the sort of top level 10,000 foot description of it is you're able to use Razor syntax and .NET inside of your browser.
So without Blazor, we were having to feed the browser HTML and JS, which was being parsed as a JavaScript tree, and this was being parsed in the browser engine such as a V8 engine, the Jugra engine, or the WebKit engine, which was being integrated into a bytecode format. The Blazor is taking this bytecode format itself and doing some work with that. Is that right?
Yeah. So diving into the details a little bit, the idea is you write the .NET code on your computer in your IDE as you would normally, Visual Studio Code, JetBrains Rider, all those kind of tools. And when you hit compile, what happens is your apps are then compiled into .NET standard DLLs. And when you run it, what happens is the browser is sent a small amount of HTML and a small amount of JavaScript. That JavaScript bootstraps a mono runtime inside of WebAssembly, which then downloads the DLL that you had compiled, which is still a standard .NET DLL. You could, if you messed around with it a little, run it on your computer as a normal app. That is then downloaded into your browser, and then because it uses this mono runtime, your app is then started in this .NET standard runtime. So you're actually using the .NET technologies that you and I all take for granted every day, but inside of the browser because of the magic of WebAssembly and Blazor.
It's worth mentioning that the compilation is also very short, because we are able to load those DLLs directly into the browser. But from what I understand is that there is some works being done with linkers and tree shakers to make those DLL files even smaller, because right now we are having to load every DLL file to make it compile. Is that right?
That's right, yep. So the example that I give is I'm quite familiar with Newtonsoft JSON, or as it's sometimes known, JSON.NET. And that in itself is roughly a 15, or rather the version I use, version 10.11, is a 10 to 15 megabyte sized DLL file. So obviously downloading that to the browser to start your app is, well, it's ridiculous, really. You don't want to sit there and wait for 4, 5, 6, 7, 8, 9, 10 seconds for this to download before your app can start. So what happens is the compilation tools do a bit of tree shaking, and what they do is they look through all of the APIs that you are calling in your DLLs. So let's say you're using JSON.NET and you're using deserialize of type T, and that's all you are using. Well, what the .NET Core CLI does, the command line tools and the build tools, what they do is they effectively recompile that DLL and remove everything that you're not using. So instead of it being maybe a 10 megabyte download, it's now 5 or 6 kilobytes because it just includes the APIs and methods that you are using and all of the private and protected things that it needs. But it's just including those paths that you are using because it's pointless sending up all of this code to the browser that you're not using, if that makes sense.
Yeah, I agree with you. There's also Mono, and Mono has been used before in other cross-platforms apps, especially with Xamarin and Unity 3D. It allows for running your app in iOS and Android and other platforms as well. And this is great, especially for C#, which is allowing its developers to write C# code for iOS devices. There is Blazor.js and Mono.js. Those files are loaded in the Blazor library, and these are loaded because WebAssembly itself is not able to support certain features at this point. Is that right?
Yeah, that's almost precisely it. So WebAssembly itself is essentially just a runtime similar to the JavaScript runtime. In fact, it can only do things that JavaScript can do because it runs kind of in the same sandbox, if that makes sense. So because of that, WebAssembly itself can't really do much in the way of advanced features. So if we want to leverage .NET, we need to load a .NET-like runtime into WebAssembly. So that's why we run Mono. So Mono.js essentially is just a bootstrapper and a couple of debug things, so it catches the errors that the Mono runtime throws. So Mono.js pulls down what's called Mono.wasm, Mono.wasm. So Mono.wasm is a version of Mono that is compiled for WebAssembly, and that essentially sets up the entire runtime. That's effectively the same as installing the .NET framework or installing .NET Core onto your machine. And then what happens is Mono.wasm is then passed a bunch of stuff to start the Blazor runtime, and then the Blazor runtime is then told, hey, this is the app that you want to start. Here's the DLL for the entry for this app. And then at that point, that's maybe your client application. It then starts performing the startup for your app. So let's say one of the examples that I give is I built a front end for the Pokemon API because I'm a bit of a video gamer, you see, and my front end is entirely in Blazor. So the first thing it downloads is a DLL called pokeblazor.dll, which is my entry point to the app. And then it downloads all of the dependencies. So it may download system.io and system.net and system.link or newtonsoft.json or something. And then my app starts, and all that my app does is it draws a small text box on screen. You type in a number, an ID of one of the Pokemon, and you push search, and it does a HTTP web request to the server. The web request comes back. It then deserializes the JSON that comes back into a C# object, which is the most important part for me, a C# object, which is then used as the view model to display on screen. Which to me, that's for my personal use cases, using C# models, POCOs, the C# files, the classes inside of the browser is the huge innovation here. There's a lot of innovation going on in Blazor, but the biggest part for me is that I no longer have to have a JavaScript model or a TypeScript model and a C# model and keep them in sync, keep them synchronized. If I add something to the C# model, I need to go back and add it to the JavaScript model. Whereas in Blazor, if I add it to the C# model, it's already there in the view, if that makes sense.
Yeah, I agree. That is very good also for parsing it, make it more efficient. .NET is very stable compared to JavaScript. It has been updated for many years. It is actually 18 years old, and the current .NET runtime is considered just as fast as some lower level languages. Got Visual Studio IntelliSense. Now, Visual Studio has been one of the best code editors. Still, we have others like JetBrains, but Visual Studio is also free for the community. Now, Blazor is a web UI framework, right?
That's right, yep. So it uses this idea of, so if you're familiar with Angular or React, there's this idea of components. So they look like HTML tags, but they're actually just almost like template placeholders, a bit like how the ASP.NET Core Razor tags work, in that it's not a real HTML tag, but it's replaced at runtime or at build time with the actual HTML that component represents, similar to how Angular and React work with their components, as I said. So the idea is that you build up your Razor syntax for a view, and then you can pass that view into a parent view or a grandparent view, along with a bunch of what are called properties. So you can pass in a parameter or a property for maybe something you want to display on screen. So maybe you have a welcome message component, and in that welcome message component, you have maybe a H1 or a H3 tag. And inside of that H3 tag, you want to have a message, but you want to have it different every time the page loads. Well, you could pass in maybe a GUID or a random number into that component, and then every time you hit refresh, a different GUID or a different random number would be passed in, and then the value would change every single time you pushed refresh. Now that's pretty useless as an example, but you can imagine that perhaps you're sending in your view model through these parameters, and you can the very latest version of Blazor, as we record this, 0.70, allows you to pass in CSS properties or theming properties as well. So depending on where your component lives, you can change the styling of it when the page is rendered as well.
And what I understand also is it is used to create markup, especially for ASP.NET Core applications or MVC applications. Blazor itself is based on C#, Razor, and HTML. Let's break down the Blazor framework even more. We have components in it, similar to a single page application component. Then we have the DOM. What I understand, it is a virtual DOM. What does that mean, a virtual DOM?
So it's very similar to how, it's similar to how React and Angular work, in that when you tell Blazor, hey, this is how I want you to alter the DOM, it doesn't actually alter the DOM that your browser is using. It alters a copy, and the reason for that is if it alters the actual DOM, there's a lot of repainting work needs to be done and lots of actual heavy lifting by the browser. Whereas if you interact with a virtual DOM, you can take a delta, just the parts that have changed, and say, hey browser, swap that div or that H3 tag or that A tag for what I'm about to pass you. And then instead of having to redraw the entire page, the browser just has to redraw the section that has changed.
So Blazor does the diffing between the virtual and the actual DOM.
Yes, that's right, yep.
We also have component models, which is similar to the model view model type, which is also similar to WBF. Then we have a feature that is included in most modern technologies, which is dependency injection. Now, do you know what dependency injection is?
Well, let's see. It's part of Solid. So there are a bunch of software engineering principles, computer programming principles, and Solid is one of them. And part of Solid, that's is an acronym, and each of the letters means something very important in software development. But the idea is you want to avoid having to use the new keyword, because as soon as you use the new keyword, you're tying your code base to an actual instance of a class, which means that when that class changes, potentially your application changes. So what you would do is you would provide an interface instead. You would say, use this interface and get me a property or get me a method or run this thing on this interface. And the interface will match the class that you're using. So dependency injection says at runtime, at some point whilst you are running, every time that I call my iFoo interface, for instance, or my iPokemon interface, actually replace it with an instance of the Pokemon class or the Foo class or whatever it is that my interface matches, and do that for me, so that then if something changes, the runtime is managing it for you rather than you, because if you're if you're managing it, it becomes a bit difficult to manage when your dependencies change. So by injecting your dependencies, you're doing it at runtime, which means that it's easier for you to make changes at build time and it not be a massive problem. So the way that Blazor handles dependency injection is that you can build up your Blazor views and and pages using the Razor Pages model. And the Razor Pages model is kind of along the lines of, it's a mixture between a CS/HTML view and how web forms used to work. If you're familiar with web forms, you would have a view and a code behind. Whereas in MVC, we're used to having a model as a C# object, a view as a CS/HTML file, and a controller as a CS class. Well, a Razor page kind of combines all three of those together, in that you might have a, let's say you have a Pokemon page, and the Pokemon page would have Pokemon.CS/HTML, and you would also have a Pokemon.CS file. The CS file would have all of the C# that sits behind that view, and the CS/HTML would be your view. But with Blazor's dependency injection, you can literally put at the top of your CS/HTML @inject, and then inject something in that you need. So let's say you need to use an HTTP client factory. You can do @inject system.net.http client, and you would have the HTTP client available in the view or in the C# model behind it for you to use. And the Mono framework and Blazor would handle passing all of those in for you. So you don't have to go get me a new instance of this and put this thing in and set that property and all this kind of stuff.
That is great for optimization, I think. Now, before you had to literally go through a plugin if you wanted to do something that the browser cannot, for example, flash games. And this was not viable for mobile, but with WebAssembly now, Blazor can work even with mobile devices. Another good thing is security. We are not relying on a third party. We are staying on the browser. It is $10.
Just on the back of the security part, if I can.
Yeah.
So obviously with JavaScript, it's just plain text. So if I'm a malicious actor, I can open the JavaScript that's loaded onto the website, put a breakpoint in, change the value of some model that I'm posting back to the server. Then if there is no validation on the server, then the data I have just sent will be written to the database, right? So I could, perhaps if I know that the website that I'm communicating with has a SQL injection vulnerability, I can add some SQL injection into the payload that's being sent to the browser. However, because Blazor runs our .NET DLLs, they're all compiled to IL. So unless you're able to inject an intermediary language debugger into your browser, you can't get to that detail and change the detail before it's sent to the server, if that makes sense. Yeah, so in that essence, the Blazor is slightly more secure in that an average user cannot change the data that is sent back to the server. Can I just say as well, just real quick, there are two types of rendering for Blazor. There's client side, which is what we've been talking about so far, which is loaded to the client, and then the client runs it has a virtual home and it has the .NET assemblies in your browser. But there's also server side as well. So that is really different in that what happens is when you load server side rendered Blazor application, what happens is your browser will download a tiny amount of HTML and enough JavaScript to bootstrap your application. But all of the rendering and all of the actual control is done at the server side. So you'll have the same view. So if we go back to my PokeBlazor example, and I can link you to PokeBlazor so that people can have a play with it if you like.
Cool.
The server side version of it, you still see the same view, but when you hit search, the message is sent over to a server. The server then does all of the hard work of hard work in bunny quotes, but it creates an HTTP client, communicates with the external API, brings the data back, parses that data, changes the DOM on the server, and then sends the delta through to the client. So the client at this point is doing absolutely nothing. It's just waiting for the server to tell it what to change. So there's an extra level of security that you can add to your Blazor applications should you need it. If you have a persistent internet connection, you can have absolutely everything done on the server and nothing done on the client. So then you don't have to worry about, like I said earlier on, somebody putting a debugger statement into your JavaScript, changing the payload that's sent to the browser, and then sending it on, because there is no payload to send to the browser. And the way that works is it sets up a signal R connection to the server. And that way, whenever the server has more data for the client, even if you haven't pressed a button, it will still send that data through. A delta will be applied, and the new component or the new data will be shown on screen.
You can have everything on the server side itself also.
Yes. So yeah, if you're worried about security, you can have everything done on the server and just send the delta for the view through to the virtual DOM, which is then repainted into the DOM.
Blazor is still in development. It is about 6 months old. From what I understand, at this moment, there is no debugging features in the browser for Blazor. So how do you debug Blazor code? Is it from Visual Studio?
Yeah. So when you're in Visual Studio or Visual Studio Code, you can put breakpoints into your C# code that's running on the browser, and through a combination of browser link and what I like to call absolute magic, because I don't quite understand how that bit works. When those breakpoints are hit, your Visual Studio or Visual Studio Code instance will actually hit that breakpoint and stop and say, hey, I'm ready for you to debug.
That is very good. There's documentation for Blazor on blazor.net. It explains you how to install Blazor for Visual Studio with the .NET CLI. Where else do you find information on Blazor? On Stack Overflow?
Yeah, so there are a lot of resources out there. Even though Blazor is still pretty young, the .NET community has really come forward and has really put lots of effort into providing lots of documentation. So one of the easiest ways to learn how Blazor works is to actually go and get the source code. Because Blazor is part of ASP.NET Core, it's all on GitHub for you to go and inspect and figure out, oh, right, so that's how that works, and that's how the render tree works, or that's, you can learn it from a very deep level if you go and inspect the code. Or like you say, there's Blazor.net, which talks you through how to build a bunch of components and a whole app with, I think it's maybe 14 or 15 pages. There's not very much. As impressive as Blazor is, it's incredibly simple to use. So there's not that much that you really need to learn. So definitely I would start with Blazor.net. And then if you can find any open source Blazor applications. So for instance, the first one that I found is a Whois clone. So this loads a page and you can do a Whois on a website. Now that one's good, but it was built before the tree shaking. So to load that page, I think it's Whois Blazor.azure websites. To load that one, you need to download 17 megabytes of .NET assemblies. So that one's not that great because it was built at Blazor 0.10. Whereas if you take a look at PokeBlazor, which again I'll link to you so you can put them into the show notes or that kind of thing. Yeah. The entire source code is on GitHub, and there is an example website as well. So you can read through it and go, oh, right, yeah, that's how that works. So that's how that works. Or you can pull down, if you have the .NET Core CLI and the Blazor templates installed, you can run .NET New Blazor, and there is a full example app built for you. It's scaffolded for you. So, even then, most of the hard work of setting it up is kind of done for you. Yes. So you can just read how other people have used it if you need to. But like you say, there are Stack Overflow communities, and I believe there's a Gitter community as well, and there are Slack communities, and there's all sorts. It's incredibly wonderful how fast the .NET community has adopted Blazor and gone, yes, this is brilliant. Let's teach everyone about it.
You mentioned that you can create something from the .NET CLI itself. Yeah, I also found that you could create a Blazor app there. You could also create one on Blazor with a server option, I think. You have two options for creating Blazor app from the Visual Studio or .NET CLI, and I think this is also very useful. You also mentioned that the tree shaking was added recently. Is it a preview version?
So tree shaking is actually a thing that was added to, I believe it was ASP.NET Core 2.1, or maybe 2.0. So it's a recent thing that's been added to the .NET Core tooling. So you don't actually even have to do anything to enable it. It just does it for you. which is fantastic.
This is all the questions I had with regard to Blazor, and you provided me with some very good insights, me and the audience, and we are grateful.
You're very welcome.
I will be talking to you again.
Oh, it was fantastic to be on the show. It's brilliant to be connected with you and your audience today. It was a lot of fun talking about Blazor. It's a very, very interesting technology and very exciting, and it brings a lot of new things to the table, I think.
You also have your podcast. It is on your YouTube channel and also on your website, right?
Sure, yes.
You like to make games, right?
Yes, but a lot of my games are pretty silly. For instance, I have one called Runaway, which is you play as a prince and you have to run away from a monster for as long as possible. And your character gets tired, so they slow down. And they can't, you know how like if you run for a long time, you get a little tired and you have to sort of walk for a little bit to catch your breath. Well, the prince does that, so you have to keep running and running and running, and then your character slows down, and then you have to kind of be strategic about how you run away. But the monster doesn't slow down, so you have to, it's interesting. I have a little timer that runs to see how long people last, and people who play it usually only last about a minute. But I can totally link to that if you think that your listeners might be interested in playing, and maybe they could get in contact with me and tell me how long they last.
Yeah, is it a browser game or mobile?
Yeah, so this is HTML5. So I don't think so. This is from I think I built it in 2014, and I was just learning how to do HTML5 stuff, so it doesn't support mobiles, unfortunately. So you will have to play it on a desktop or a laptop. So it doesn't support touchscreen. But I think I'll have to go back and add touchscreen support to it.
That's a great game. I also make games on Unity 3D. You might know it from the C#. It's a really great platform for all sorts of games with mobile, console or PC. I have my 2 games there. Okay, man, so you are welcome to be on the podcast anytime you want again. Also, just let me know. And how's your own podcast going?
So you mentioned it earlier on. So my podcast is the .NET Core podcast, and it is it's all about .NET Core and EF Core, SignalR, Blazor, that kind of stuff. Almost anything that falls under that core category. As of yesterday, as we're recording this yesterday, so Friday, whatever yesterday was, the 23rd of November, I released the 13th episode of the podcast. They've so far been once every week, and I've had people on like Jeff Fritz from Microsoft, Ed Charbonneau from from Telerik, sorry, and we talked about Blazor. I've had Steve Gordon, who's a UK Microsoft MVP. I've had Thomas Hansen, who's working on a new server-side scripting language called Lizzie. It's been and Dustin Metzger, who works for Uber. We were talking about all sorts of stuff. So yeah, it's been quite interesting. If your listeners want to check it out, perhaps that's available at .netcore.show, DOTNETCORE.SHOW. And on there are links to, YouTube or if you're Stitcher and things like that, and Apple Podcasts and stuff. But yeah, that's going pretty well. I tell you what, why don't we have organize it outside of this podcast episode, but why don't we have you on the show as well to talk about your experiences with, say, Unity 3D or Mono or something? That would be really quite interesting.
We can organize something, and I would love to talk about my own experience. I'm also a .NET specialized developer, so we can have something good on your channel as well.
Fantastic. That sounds pretty cool.
Yeah, I agree. I would like to talk about some advanced stuff, especially with ML.NET. Machine learning.NET is something that I'm working with at the moment, and it's really cool.
Sure. Yeah, let's organize that outside of this podcast episode and see if we can get you on my show as a sort of return the favor, as we might say in the UK. Return the favor.
Great. Okay, man, I'll stop here and we can talk again for your podcast.
Sure.